So if a circle has a diameter of 15 centimeters, how would we find the radius? If I have a diameter of 15 centimeters, how do I find the radius? Divide it by 2. Radius is equal to diameter divided by 2. So that means the radius is equal to 15 centimeters divided by 2. And what is 15 cut in half? 7.5. So the radius is 7.5 centimeters. How do we find the diameter if we know the radius? Multiply it by 2. Diameter is equal to radius times 2. So the diameter would be equal to 2 times 24.5 feet. And what is 2 times 24.5? 49. So the diameter is 49 feet. Very nice work. We are going to be in your extra notes now for the rest of our time together today. We're going to start section 2 today, and we will finish it up tomorrow. So we're on page 3 in your extra notes. Unfortunately, the pages didn't get numbered this time, but we are on the second piece of paper, what would be page 3. There's a little bit of new vocabulary that we have to add today. The first one that we're going to talk about is a central angle. A central angle is an angle formed by 2 radii that have a common endpoint. The vertex of the angle is the center of the circle. So a central angle would look something like this. So angle PQR would be a central angle. An arc is the portion of the circle that is contained between 2 points. A minor arc on a circle is less than 180 degrees. So giving you an example of a minor arc here, let me go ahead and draw in a central angle. We're going to call this angle ACB. This right here is arc AB, which we write with the letters, and then we put a curved piece over the top. If my central angle, in this case that would be ACB, if that is an 80-degree angle, so I'm going to come over here and add that to the picture. If that angle is 80 degrees, then arc AB is also 80 degrees. The minor arc has the same measurement as the central angle. A major arc has a measurement that is greater than 180 degrees. So again, I'm going to draw a central angle on here. We're going to call it the same as the one up above. And I'm going to put an extra point over here. This arc right over here would be a major arc. That is more than 180 degrees. And to make sure that I don't get it confused with arc AB, we're going to call this arc ADB. It has to also contain the point D. You're welcome. If the measure of angle ACB is 80 degrees, then my major arc, ADB, is equal to 360 degrees minus 80 degrees. And I should have a measurement in front of my arcs. Whenever I give an angle, or sorry, a degrees measurement for my arc, I need to have the measure of that arc. So it'd be 360 minus the 80 degrees for my central angle and my minor arc. No, I'm saying if that angle happens to be 80 degrees, then the arc has the same measurement for the minor arc, and the major arc would be 360 degrees minus the size of the minor arc, because all the way around a circle is always 360. And then we have a semicircle. A semicircle is exactly 180 degrees. So a semicircle is formed by a diameter. We're going to call this diameter FG. So then this would be arc FG. And the measurement of arc FG is 180 degrees. Measurement of arc FG is 180, and segment FG is a diameter. So arc FG is a semicircle. That means it measures 180 degrees. And the segment that would be my central angle there is a diameter. All right, let's start looking at a couple problems now. Quick reminder, one full revolution around a circle always measures how many degrees? 360. All right. Number 1, part A, they want us to find the value of x. X is right here. So I'm going to look at all these central angles. How many central angles do I have there? Got one here. How many other central angles are there in the picture? Here's the second one. How many central angles total are shown in the picture on part A? 4. There's one where the x is, one where 85 degrees is. There's one that's 40 degrees. And how big is this one, BAE? 90 degrees. They have that right angle mark in there. And I know that all of those angles have to add up to how much? 360. X degrees plus 85 degrees plus 40 degrees plus 90 degrees equals 360 degrees. Got a whole bunch of like terms right here that we need to combine together. Can somebody add 85, 40, and 90 together for me? How much? 215. You said 215? Yes, sorry. I'm like mishearing things today. So x plus 215 equals 360. I'm going to subtract 215 from both sides to isolate x. And what is 360 minus 215? 145. So x is 145. Part B, how are we going to figure out how big x is right here? Yes, x plus 145 plus 165 is going to add up to 360 degrees. What is 165 plus 145? 310. So x plus 310 equals 360. And then we're going to subtract 310 from both sides. And that means x is how big? X is 50. Nice work so far. All right, so we can find measures of missing central angles. We can also find measures of arcs. Let's look at numbers 3 and 4. So on number 3, it tells me that PM is a diameter of circle R. So this right here is cutting my circle exactly in half, which means this arc over here, PQM, would be how big? 180. All right, we want to figure out how big arc MQ is. Well, MQ is right here. How am I going to find that arc? Yes, 180 minus 115. We're also supposed to name whether it is a major arc, a minor arc, or a semicircle. Is MQ a major arc, where it's bigger than 180, a minor arc because it's smaller than 180, or a semicircle because it's exactly 180? This is a minor arc. Yep. Yes. To find the size of that minor arc, we're going to do 180 degrees. You're welcome. Minus 115 degrees. What is 180 minus 115? 65. So the measurement of arc MQ is 65 degrees. And then we want to find the size next of MNP. MNP. Is that a minor arc, a major arc, or a semicircle? That is a semicircle. And because it's a semicircle, that means it measures how big? 180. On part A, I forgot to put my measurement sign in front of MQ. So I have to come back and add that. Measurement of arc MQ is 65 degrees. All right, then the last one we need to find is arc MNQ. Let me come in here and mark that. MNQ, all the way around to here. Minor arc, major arc, or semicircle? Major arc. That is more than halfway around the circle. It's more than 180 degrees. Well, how big did we say arc MQ was? 65. So how could I find the measurement of MNQ? Yes, 360 minus 65. And what is 360 minus 65? 295. Let's try another one like that. This time, what is my diameter on number 4? GJ is a diameter of circle K. GJ is right here. First thing they want me to find is the measurement of arc GH. How big would that arc be? 122. Measurement of arc GH is 122 degrees. Would that make it a minor arc, a major arc, or a semicircle? Minor arc. Then they want me to find the measurement of arc GLH. So GLH going around this way. Is that a minor arc, a major arc, or a semicircle? That's a major arc. It goes more than halfway around the circle. How can I find the measurement of arc GLH? 360 minus 122. And what is 360 minus 122? 238 degrees. All right, last one for this page. The measurement of arc GLJ. Is GLJ a minor arc, a major arc, or a semicircle? Semicircle. GLJ would be this bit right here in red. So that would be a semicircle. Which means it has a measure of exactly what? 180. Beautiful. Let's go ahead and flip the page. Let's find a couple more arc measurements here. I want to know the measurement of arc WY right here. How could I find the measurement of arc WY? No, we can just add those two. Because I'm asking for WY, which when they give me an arc name with just 2 letters, it's always going to be the shortest distance between those. That's why we're just adding the 90 and 162. So the measurement of arc WY is equal to 90 degrees plus 62 degrees, which means it is how big? 152. How would I find the size of arc AD over here in part B? Add 63 plus 90. And what is 63 plus 90? I'm sorry, I didn't hear how much. 153. All right, we're going to practice naming some pieces of circles and giving measurements where appropriate. Number 6. What would we call segment DA right here? What part of a circle is that? A radius. What about segment BE? This segment right here, what would we call that? It's a diameter because it goes from edge to edge through the center. And what about BC? What would we call that segment? That is a chord. What would we call arc BE? Semicircle. And a semicircle always has what measurement? 180 degrees. Then they want to know about arc CBF. I'm going to have to erase my other markings on here so that we don't get too much going on. CBF. What kind of an arc would that be? Major arc. What would the measure of that major arc be? 190 degrees. Nice job, because we have a 90-degree arc plus the 100-degree arc. And that's how we get the 190 degrees for CBF. What would we call arc CD? Minor arc. How do I figure out how big that is? Add 90 and 50 and subtract it from 180, yes. This much right here is 180 degrees because that is a semicircle. So we're going to add 90 and 50 and subtract that from 180. What is 90 plus 50? So I'm doing 180 minus 140, which would be what? 40 degrees. So I'm going to go ahead and add that to the picture. This is 40 degrees, so its central angle would also be 40 degrees. Last thing they want me to find, angle EAF. This angle right here. How do I find this angle? Close. BE is my diameter. So this is the thing that's cutting it in half. It's 80 degrees. What would we call angle EAF? I know it's 80 degrees, but what would we call it? Like we had for arc BE, that was a semicircle. For arc CBF, that was a major arc. Arc DC was a minor arc. What would we call angle EAF? Looking for a word that starts with a C. It's not a chord. Not concentric circles. It's one of the vocabulary words that we learned just today. Central angle, yes. A central angle is formed by two radii. So that would be a central angle there. Let's look at number 7. In the circle, QT and UR are both diameters. So QT is dividing my circle into two sections of 180 each. And UR is doing the exact same thing. So these are both diameters. And then it says the measurement of angle QPU is 4x plus 11. QPU, that's this angle right here. It's 4x plus 11. First thing they want me to find is the measurement of x. Well, since RU is a diameter, what's the measurement of arc RQU? 180. The measurement of arc RQU is 180 degrees. RQU is made up of arcs RQ and QU. Well, how big is arc RQ? 45 degrees. What about QU? 4x plus 11. So now we're going to combine some like terms together. I'm going to combine 45 and 11. When I combine those, I get what? 56. So 4x plus 56. So then I'm going to subtract 56 from both sides. What is 180 minus 56? $124. Then we divide both sides by 4 to isolate x. What is 124 divided by 4? 31. So that was the first thing I was asked to find. They want me to find the measurement of arc UT right here. How can I find that? Yes, Maya. Yes, RPU and UPT are vertical angles. Well, how big is RPU or RPQ? 45 degrees. So that means that UPT is how big? 45 degrees. So how big is RQT? Arc RQ is 45. No, I just want to know arc UT, just this red, orange one right here. Arc RQ is 45. Angle QPR is 45. Angle UPT is 45. So arc UT would also be 45. QRU, arc QRU. Let me get a different color. So I want this whole piece right here. How much? 180 plus 45, absolutely. What is 180 plus 45? 225, yes. All right. Arc USR. USR. What was segment UR again? It's a diameter. If segment UR is a diameter, then arc USR would have to be how many degrees? 180. And then the last thing they want me to find is the measurement of angle SPR. SPR. This angle right here. Well, you just told me that arc UR was 180. We know that arc UT is 45. Arc ST is 71. So how do I find the measurement of angle SPR? Subtract it from 180, yes. So 180 minus 45 plus 71. What is 45 plus 71? 116. And 180 minus 116? 64. Nicely done. All right. We are going to stop there for today. Very nice work today, guys. Tomorrow, who can tell me what's special about tomorrow? We're having e-learning via just doing activities on Canvas, or are we going to meet live? We're meeting live on Zoom. Do you guys know how to get to your Zoom meetings in your different classes? All right. For this class especially, you're going to go to Canvas. You're going to log in just like normal. You're going to go to this class. And then off on the side, there will be a Zoom link. So let me go ahead and pull this up to show you guys. When you get into geometry, the Zoom link is going to be right down here. So it's going to be underneath modules, assignments, announcements, grades, quizzes, syllabus, and then this is our online book. Zoom will be right here, right above Tech Help. When you press on that Zoom link, it should show you our meeting. Let me see if I can get it to pull up correctly. So click on Zoom, and here's our meeting for tomorrow morning. We will start promptly at 8 o'clock tomorrow morning. You do not have to get up at normal time. The Zoom starts at 8 instead of at 7:15. So you'll click on this right here. It should let you into the meeting. I'll probably have it up and going about 5 minutes ahead of time, but it should allow you to join even before I have started that meeting, and then I'll admit you as soon as it starts. All right? The homework that you guys picked up on your way in the door, that is due on Wednesday. So tomorrow we'll finish up everything that you need in order to be able to do that assignment. And then when I see you in person again on Wednesday, we'll go over that homework and we'll start on section 3. Okay?